Friction. As the boat cuts through the water slows it down, creating water resistance. Buoyancy. An object placed in water is buoyed up by a force equal to the weight of the quantity of water it displaces. This means an object will float if it moves more water than it weighs, and an object will sink if it moves less water than it weighs. An object will neither float nor sink if it moves water equal to its weight. This is why sailboats can stay afloat. Bernoulli's principle. Sailboats are propelled by lift, just as airplanes fly by lift. To understand Bernoulli's principle, one must understand the Magnus effect. This states that a curved figure, such as a ball, curved top of an airplane wing, or sail of a sailboat, moving through air, will create faster moving air in the direction of rotation. This makes the pressure on top lower than the pressure on the bottom, thus lifting the plane up. In a sailboat, the sails are curved, creating the same Magnus effect. The higher pressure inside the sail pushes the boat forward. Newton's second law. This says that more mass equals more force needed to accelerate an object. Smaller sailboats can sail 5 knots with less wind pushing them, while bigger boats need more wind and force pushing them. Bigger boats also have more inertia, making them want to stay in the spot they're in. Newton's third law, which states every action has an equal and opposite reaction. As the sailboat pushes through the water pushes back on it with an equal and opposite force.
These